Here's another quick example to show how easy it is to find the vertical asymptotes of tangent graphs. So all you have to do is take the horizontal transformations from your equation, or the inputs of your tangent function, and set them equal to the parent asymptotes of tangent x. So that's pi over 2 plus pi k, where k is an integer. And then you're going to apply those horizontal transformations by solving for x, and you'll have the equation that will generate all of your vertical asymptotes. So let's show how this works with y equals tangent of x over 3. First thing we want to do is identify those horizontal transformations, or the inputs of the tangent function. So here that's x over 3, and set them equal to the parent asymptotes, pi over 2 plus pi k. All right, now we solve for x. We're applying those horizontal transformations to the original asymptotes. And it's really easy here. All we have to do is multiply both sides by 3. Just make sure you multiply every single term by 3. Okay, so on the left, we are left with just an x. Okay, so then we have 3. So I'm showing kind of what we're doing here to every term. 3 times pi over 2, so that gives us 3 pi over 2. And then 3 times pi k, so plus 3 pi k. And this asymptote equation will give you every single asymptote for your tangent of x over 3 graph, depending on which value you substitute in for k. And that's all there is to it. Now, say you want to find a particular asymptote. Well, just substitute in an integer for k. We'll do a couple here, just in case you want to see it worked out. Let's let k equal to 0 first. So just substitute in 0 for k in the equation. This one's easy enough because that 3 pi times 0 cancels, and we have an asymptote at x equals 3 pi over 2. All right, let's try it out when k equals 1. Just a little bit of calculation here. So we have 3 pi over 2 plus 3 pi times 1. Okay, so we need a common denominator here. So rewrite 3 pi as 6 pi over 2. So equivalent of 3 pi. And now we can easily add with that common denominator. So we have another asymptote at 9 pi over 2. That's just 3 pi over 2 plus 6 pi over 2. All right, and notice that asymptote is to the right of the one when k equals 0. And another great thing to notice is that they are a period apart. Our period here is just 3 pi. We basically just took that asymptote 3 pi over 2 and added a period to it. So that's how this asymptote generating equation works. One more for good measure, let's let k equal to -1. So this will generate the asymptote to the left of x equals 3 pi over 2. Okay, so we have x equals 3 pi over 2 plus 3 pi times -1. So we're really subtracting 3 pi, or with a common denominator, we're subtracting 6 pi over 2. So we have 3 pi over 2 minus 6 pi over 2. There's another vertical asymptote for our graph at x equals -3 pi over 2. Again, that one's to the left of the k equals 0 asymptote, and they are spaced apart by 1 period, or 3 pi units. All right, so hopefully this helped you understand how easy it is to find asymptotes from tangent equations, and also to generate particular asymptotes, subbing in different values for k. Don't forget to subscribe for more examples for finding asymptotes, graphing, and all sorts of other math tips.